Good evening, everyone. I'm going to present our work entitled Satellite-Derived Vegetation Indices and Radar Metrics as Proxies for Tabermelanosporum mycelium dynamics. Our work is part of the Taberlings project, and we carried out with researchers from IRTA in Catalonia and CSIC in Madrid. And the main goal of this project is to optimize truffle orchard management by studying the soil-plant fungus complex. So, as Alba said before, the black truffle has a very economic and gastronomic importance in our country, and Spain is a global leader in truffle production. So enhancing its cultivation is vital for the rural and the country bioeconomy. So the integration of remote sensing in black truffle studies has never been explored before. So this is why our project is very innovative. So we ask ourselves a simple question. Can remote sensing provide us indirect information about black truffle mycelium activity? So our idea was to look for signals that can reflect what is happening underground. So the main objective of this work was to explore relationships between remote sensing optical and radar metrics and the black truffle mycelium biomass. This study was carried out for several truffle producing regions in whole Spain, as you can see there in the map. I have to say that we had a highly valuable ground truth data, that it is quite important in this work. And we employed a total of 492 samples. Each sample refers to a single tree, and we also took, or there were taken soil samples with the milligrams of mycelium. And these samples were divided into truffle managed plantations that were 288 and hallmark natural forest that were 204. And also these old samples were collected for 4 different campaigns that are where the maximum peak of mycelium is, that are the autumn of 2019 and 2020 and the spring of 2020 and 2021. So we followed this methodology. We employed images from optical sensors that were the high resolution PlanetScope and the Sentinel-2, and we calculated optical indices for these 2 sensors. We calculated the NDVI for the PlanetScope and the NDVI and several moisture-related indices to the Sentinel-2. And later we employed Sentinel-1 images that are radar images. And we extracted the backscatter values for these images that in 2 different polarizations that were VV and VH. We extracted all of this data for a buffer of 50 meters around each tree, because the mycelium spreads around the tree and we wanted to see what is happening with the mycelium. And then we related these values with the milligrams of mycelium. So we also included geographic factors in the study. We included the altitude and the region. And the altitude, we divided samples into 3 different clusters. One below 700 meters, another one between 700 and 1,000 meters, and another one above 1,000 meters, as you can see where I distributed in the map. And there also we divided into different regions. In one of the Iberian system, another one the Ebro Basin, and another one the Pyrenees. So our main results are for planet scope sensor, that we have limited explanatory power, except for the spring, that we had a significant relative negative relationship between the NDVI and the mycelium. For the optical sensors, that would be the Sentinel-2 sensor. Also, we had a limited explanatory power, except for moisture-related indices that slightly go better, but they weren't significant. So, in contrast with the radar data, surprisingly, we had a significant negative relationship with the mycelium biomass that was higher in the spring. And we saw also that the mycelium biomass increased with the altitude. That was surprising. And the region showed no clear pattern. So as you can see here in the graphs, the green points represent altitudes above 1,000 meters, and they are related to higher amounts of mycelium, and also the radar values, the backscatter values, are lower. So this is the main relationship. So our main conclusions are first that radar backscatter outperform optical indices in explaining mycelium biomass, that mycelium biomass showed a strong altitudinal pattern, that it was higher at a higher altitude. Radar signals likely capture soil moisture-related processes linked to fungal activity. And finally, that radar data are a valuable proxy for studying below-ground biological processes. Thank you very much for your attention.